Hi, in this lecture I will be doing a discussion on the structures for realization of the digital IIR filter. In the previous lecture I have discussed about the design steps of the digital IIR filter, and in this chapter I will be doing a discussion on how we can do the realization of the digital IIR filter. Normally we are given with this kind of transfer function in terms of hz for for the realization of the digital IIR filter. We are being given this transfer function and we have to follow all these steps to transform it into a kind of equation in the discrete time domain, and we can transform that equation into this kind of logical diagram, and this is being said as the realization of the digital IIR filter. And we are using in this diagram summers, multipliers and the delay elements. So let's see this example how we are doing the realization of the digital IIR filter. This is a transfer function of the digital IIR filter in terms of Z form, and we know that hz is equal to output over input. We do its cross multiplication over here. Y multiplies inside, x multiplies inside. We are doing the inverse z transformation by using the time shifting property, and we know that once we do yz transformation it converts into yn, and with the delay element yz it converts into yn minus 1. This is a delay output, and z minus 2 into yz will convert into yn minus 2, and xz will convert into xn, and z minus 1 into xz will convert into x into n minus 1. And we have rearranged the values of the terms of the equation on the right hand side with only yn on the left hand side, and we will construct this kind of diagram. And we have over here the xn, we have the yn, and we want the values of yn minus 1 and yn minus 2 as we have in this equation: yn minus 1, yn minus 2 and xn minus 1. And for all these values we will be using the delay elements. So to get the value of xn minus 1, we will be having a delay element over here. It will give us xn minus 1. We can multiply this value with minus 1 to get this minus x minus 1. Because it is not given over here, you can put minus 1 over here, and then we delay the value of yn with the help of z minus 1 to get yn minus 1, and then multiply it with minus 2 to get this y minus 2y n minus 1. And similarly we want to get yn minus 2. We have a delay element over here, and we have yn minus 2, multiply it with minus 3, and we summate all these values, we do their summation, and then we have logically drawn this equation, and we have do the realization of the digital IIR filter. Another example we can see, this is example number 2. By doing all the steps which we have seen in the previous example over here, we can use all those understanding, and we can transform this equation into this equation into discrete time form, and then we can logically draw this kind of diagram from this equation. Okay, so another example, we over here we have another kind of transfer function. We are using the same method, and we are converting that equation into a discrete time form from z form into discrete time form. And then we are, with the help of delay elements, with the help of multipliers, with the help of summation elements, we logically draw this equation into a diagram, and this is the realization of that digital IIR filter. Another equation over here, we first do its simplification, multiplication of the denominator, and then we are following the same method and this kind of equation, and we have we can convert that equation into a logical diagram. So this is a lecture in which we have understood if we are being given the transfer function of the digital IIR filter in the form of Hz, then how we able to convert it into Yn, and how we able to convert that Yn equation into a kind of logical diagram and do the realization of the filter. Thank you very much.